Hi, I'm Gavin.
Hi, I'm Ryan. We are doing the 555 timer as the Astable multivibrator.
Now we could have had it set up as a monostable or a bistable multivibrator, but this is probably one of the most simplest to get into.
So because we picked the Astable multivibrator, we have the only circuit that doesn't require any push button inputs to turn the LED.
Now let's talk a little bit about these 555 timer chips.
These chips have 8 pins and are capable of handling anything between 5 and 15 volts. They bring electricity directly across the chip from pin 8, the supply voltage, to pin 1 that grounds it. The threshold and trigger pins are connected to comparators that measure 1/3 and 2/3 of the supplied voltage. Now those will send a false or a positive to a flip-flop and turn the output pin on and off. But these signals can be overwritten by the reset pin.
Now every time that output pin opens up, energy is going to flow through our LED. Now I'll let Ryan explain to you how we find how long the LED is going to stay on.
We are going to calculate the time constant, which is resistance times capacitance. In our case, it is the resistance, which is 10,000 K times 100 microfarads, which equals 1.
Now that we have our RC time constant, we can plug that into our capacitor equations and figure out what its voltage is at any given time. So as an example, we can find the voltage across our capacitor during its third time constant while it's discharging and charging. So we'll plug 3 in for our number of time constants over 1 for our RC time constant. So we'll use the e to the power of x button on our calculator to put e to the power of -3. Then we'll hit equals and multiply all that by 9 volts, which should give us around half a volt. Now if we wanted to see what the voltage would be charging, we would just back up a couple of steps and instead subtract what you got for e to the power of -3 from 1 before multiplying by 9 volts. This time we should get around 8.5 volts.